Hello everyone, welcome to our channel Coders Arcade. In our earlier videos, we covered Module 1 and Module 2 of the 5th semester subject Application Development using Python. Hope you have gone through those videos. If not, then I will give the link in the description below. Please like, share and subscribe to our channel Coders Arcade and press the bell icon to receive notifications about our new uploads. This video is related to Module 4, so let's start with this Module 4. Welcome to Module 4 of the VTU syllabus covering the book Application Development using Python. The Module 4 is based on the book Think Python and it covers the chapters 15 through 18. As these chapters are totally based on object-oriented programming concepts where you will have to deal with classes, methods and many other properties. So before that, I want to give you a brief overview of the object-oriented programming principles. So you might have already learned about object-oriented programming in Java and C++. So let me introduce you to the object-oriented programming concept in Python. So let us start. Here I will show you a diagram which will give you a pictorial representation of object-oriented programming and the keywords which you have to remember in this case. So here you can see this is a pictorial representation of object-oriented programming where there are classes, then classes will have objects and the objects of the classes will have certain properties which are known as attributes. Here in this diagram, you can see that at the top level will be the class, which will actually be the main entity. In the class, we have the name of the class here, which is apartments. This is the main entity, apartments. This is a class. And in a class, we can define many objects. The objects will be the instances of the class. So in this case, these are the objects: Salarpuria, Brigade and Prestige and many other types of apartments will be the objects or the instances of this apartments class. Now, all these apartments have certain common attributes or properties. The common attributes or properties are name, price and size. Name, price and size, and again name, price and size for all the three types of objects. So like this we can divide the diagrammatical representation of classes so that you can understand it in a very different and very easy manner. So here, as I told you, the class is the main entity. Here in this case it is apartments, and finally you will be having the instances or objects which belong to this class apartments. Here the instances or objects are the types of apartments, the different names for the apartments which are Salarpuria, Brigade and Prestige. Now these three types of objects or apartments actually have common attributes which are name, price, size. So these attributes will be common for all of the three. That's why these are actually the attributes of this class and this will be assigned to the instances or the objects. So let me go to PyCharm where you will get a better idea of this program. I will implement the same pictorial representation with the help of a program so that you can understand about the object-oriented concept in a very good way. So let us go to PyCharm now. Here you can see I have defined the class apartment. Now you have to remember that you should always write the name of a class with the capital letters. It is not mandatory to write the name of the class with a capital letter, but it is a convention followed by Python where you have to write the name of the class in capital letters. Now after that, this is the doc string which actually tells what this class apartment is all about. So this class apartment is to define a variable called apartment. Now in this, these are the class attributes or class variables which I will
tell you later, but first of all, let me tell you how to define the attributes of the objects. For that, you have to use the init method, which is also known as the constructor or the magic method. Here, the init method will take by default the first argument, which is self. Now, as soon as you create an object, the attributes will be assigned to the objects with the help of this self. So, whenever we define an object with the name say brigade, then it will be referring to this self.name and the name brigade will be saved to this attribute. And in the same way, I have taken the next argument, which is the next attribute, which is square feet price. So, in the same way, self.square feet price means that we are assigning another attribute to this class, which is the square feet price. Then what we are doing is we are again defining another method which is called getName, and then it takes the default argument self. You have to remember in this case that whenever we define functions inside the classes, they are known as methods and they take the default argument which is self. If you want to provide any other arguments, you have to override them and write any other arguments which you want to use in future. Now in this getName method, what I am doing is I am trying to print the apartment name by calling the attribute self.name. So this self.name will actually go and look into the init method and find the attribute name here, and it will print along with the name of the apartment. So here after the apartment name, I should find the name of the apartment. So this is the use of this getName function or method. Now after that, I have used the getPrice method, which has again the default argument which is self. Here what I am doing is I am trying to print the square feet price. Now let me go on to the class variables, which are flat size in square feet. I have taken the class variable flat size in square feet, which is actually 1500. Then I have taken another variable cost, which is the class variable, which I have assigned a default value 0. So now as soon as I print the square feet price, I will use the self.square feet price process, which will again go to the init method and then it will invoke the attribute from here and it will print it here. After that, I have used the class variable cost, and you can see the convention of calling this class variable. I have to use the name of the class. Say here I am using the name of the class, which is apartment. You can see here. Then I am using the dot operator. Then after that I am using the name of the class variable. Like this you can call the class variable. Then it was default set to 0. Now I am changing the value of it. What I am doing is I am using the flat size in square feet, which is also a class variable, which is assigned the value 1500. I am using it by calling the name of the class using the dot operator, and you can see after that I am calling the flat size in square feet variable. So now here I should get 1500, and then after that I will find the square feet price. The square feet price has to be given by the user when we define the objects. Now after that, finally I am printing the cost, which will be this apartment.cost variable, because it has been updated after this operation has been done. Now let me show how to instantiate or create an object. Here I want to tell you one thing. The process of instantiating an object is known as instantiation, and object and instance will be the same thing and they refer to the same thing. They have the same meaning. So in my further topics, I will be using the name object and instance in different ways, but you need to remember that when I say object or instance, they will refer to the same entity. Now here I have created a new object. This is the convention for creating an object. I have created an object A1 where I am calling the name of the apartment, and under brackets or parenthesis, what are the attributes? The attributes were name and then the square feet price. So here if I give the name brigade and after that if I give the square feet price to be 5000, then I have to call the getName method so that I can get the name of the apartment. And again, I have to call the getPrice method so that I can get the price of this apartment. Now, let me show you how to do that. Here I have used the a1.getName. So this is the name of the object. After that, I am using the dot operator. I will show you, I will delete this one so that you can understand. I am deleting it, and if I write get, you can see it's already giving me the suggestion of this getName. So when I use this a1.getName, I am calling the getName function or the method defined in the class. Again, when I give a1.getPrice, I am trying to call the method getPrice defined in the class body. So now, when I run my program, you can see that I will be getting the results. I am running it. You can see for the first line of code, which is a1.getName, it is calling this getName method and it is printing the apartment name, which is self.name. In this, the name is Brigade. Therefore, we are getting apartment name as Brigade. And after that, when I am calling the a1.getPrice method, then in this, you can see that first it will print the square feet price. So here, we are getting the square feet price as 5000 because here we assign the value 5000 to this attribute square feet price. After that, you can see that this print statement is getting printed. So the cost is apartment cost. Here you can see that the apartment cost will have 5000 because the square feet price is 5000. We assigned it and it will have the flat size in square feet, which is the class variable. Now you can see this is 1500. So when 1500 is multiplied by 5000, because I have used a star, this means multiplication, it is yielding us the value which is 1500 into 5000. So the result is 75 lakhs. So this is a brief overview about how to use classes and then instantiate objects in the object-oriented programming method. Now, when I move on to the further topics in the module 4, you will find it easier to understand because now you have a rough idea of what actually constructors are and what actually methods inside the classes are, and also you already know about this self, which is the first argument by default in any method inside a class. So now I will again go to this pictorial diagram, and here I will show that what I told earlier. This is the main entity, which is the class. Here in this case the name of the class is apartments. This apartments has Salarpuria, Brigade and Prestige as 3 objects or instances, and finally these objects have attributes or properties which are name, price and size. Name, price and size, name, price and size for all the 3 of them. So these attributes have to be defined in the init method at the beginning of the class. What is the advantage of doing this? Because in this way we can create as many objects as we want. Whenever we want to invoke the attributes, then we can easily use them by using this kind of method. Say a1.getName, then you can easily invoke it from this init method. This is the advantage of using the init method. And by default, object-oriented programming in Python always uses the init method. There are many other methods like __str and many more, which I will be covering in the further topics of this video. So now with this, let us move on to module 4, which is chapters 15, 16, 17 and 18 of the book Think Python. Now that you have got a brief overview about object-oriented programming in Python, let us move on to the syllabus. Now, the syllabus here is in the second book, which is named Think Python. Let us move on to the chapter 15, which is actually the module 4 of the syllabus. Now, in chapter 15, we have classes and objects. So now, at this point, you know how to use functions to organize code and built-in types to organize data. The next step is to learn object-oriented programming. I have already given you an overview in the first example, but let me tell you more about object-oriented programming. In object-oriented programming, we use programmer-defined types to organize both code and data. Object-oriented programming is a very big topic. Therefore, it will take a few chapters to get there. So let us start with the first topic, which is programmer-defined types. Now, we have many built-in methods in Python or the built-in types in Python. Now we are going to define a new type. As an example, what we will do is we will create a type called point that represents a point in two-dimensional space. Let us start it. Actually, in mathematical notation, points are often written in parentheses with a comma separating the coordinates, the x and the y coordinates. For example, if we have 0, 0, it represents the origin and x, y represents the points x units to the right and y units up from the origin. Now, there are several ways we might represent points in Python. These are the ways. We could store the coordinates separately in two variables x and y. We could also store the coordinates as elements in a list or tuple. Otherwise, we could create a new type to represent points as objects. Creating a new type is more complicated than the other options, but it has its own advantages that you will be knowing soon. Now, a programmer-defined type is also called class. This is an example of a class definition here. This is class point. This is a docstring which actually tells what the class does. Here it says represents a point in two-dimensional space. The header here, this class point, it indicates that the new class is called point. The body is a docstring that explains what the class is for. You can define variables and methods inside a class definition. But we will look into that later. Right now, let me show you how to define a class which is called point. Now here, when we try to print point, you will get this class underscore underscore main underscore underscore dot point. What does it mean? It actually means that point is defined at the top level. Therefore, its full name is main dot point. So this is a simple logic to understand why it is written underscore underscore main underscore underscore point. Just because this point is defined at the top of the class, therefore it is known as the main point. Now, let me show you how to create objects. Actually, the class object is like a factory for creating objects. To create a point, you call a point as if it were a function. So, class can also be called like we call functions. Here you can see I have created an object which is blank and then I have given equal sign and then I have called the point class and given parenthesis. So now if we print blank, what it will do is we can see that main.point object at some kind of memory location. This says that now the blank is an object of the point class at this certain memory location. Now let me tell you what is the process of creating an object called. Creating a new object is called instantiation and the object is an instance of the particular class. Now, whenever we print an instance, Python tells you that what class it belongs to and where it is stored in the memory. This is here, main.point object at this memory location. So Python tells us which class it is referring to, and at the same time it shows the memory location. Now, this is the very important thing which you should remember. Every object is an instance of a class. So object and instance are interchangeable. That means we can either tell object or an instant. Both represent the same thing, and the process of creating an object is known as instantiation. Now, let me tell you something about the attributes or the properties of objects. As soon as we know about class, then what is a class used for? It can be used for creating objects. Now, what will the objects have? The objects will have some kind of properties. These properties are known as attributes. Now, I will show you how to assign attributes to the objects in a class. Here you can see I have written blank.x is equal to 3.0. So, this is the x coordinate. This is the attribute of the point, blank. And then this is blank.y equal to 4.0. Now, what does it mean? This means that y is the y coordinate or the y attribute of the point blank. The values I have assigned are 3.0 and 4.0. That means it can be also represented as x comma y in parenthesis is equal to 3 comma 4 in parenthesis. So here this syntax is similar to the syntax for selecting a variable from a module, such as you can say math.py or string.whitespace. In this case, though, we are assigning values to named elements of an object. So the dot operator here is actually assigning values to the attributes of an object. These elements are called the attributes. X is an attribute and y is an attribute here. Now, let us see the diagram which actually will give you a very good idea about the point class. Now, this diagram is also known as the state diagram, or it can also be known as the object diagram, which shows the object and its attributes. Let us see the diagram here. Here is the diagram. Here, point is the class, blank is the name of the object that we created. This process was known as instantiation, and then you can see here, these are the attributes. X 3.0 is the attribute, y 4.0 is the other attribute. So, blank is an object of the point class with the attributes x and y, which have the values 3.0 and 4.0. Now, here I will show you one more thing. The variable blank actually refers to a point object which contains two attributes, as I told you earlier. So here each attribute refers to a floating point number, which is x refers to 3.0 and y refers to 4.0. Now let me show you. If I print blank.y, what will happen? I will get the value 4.0 because y has the value 4.0. And if I again here, you can see that I have done something different. I have taken a variable x and then I have assigned the value blank.x. Here you should have thought that this x and this x are similar, but no. Blank.x is actually an attribute of the object blank, and x here is a totally different variable. These two are not similar, these are totally different, and these do not clash with each other. Now when I print x, I will get the value of blank.x, which is 3.0. You can see here when I am printing x, I am getting 3.0. Now let me show in PyCharm so that you can understand better. I am going to PyCharm. Here I have already defined the class point, and here you can see that I have the docstring which is saying represents a point in 2D space. Now what I will do is I will show you. If I am printing point, what I should get, I told you. When I am printing point, I should get main.class. I am running it. Here I'm running it. You can see that when I'm printing point, I'm getting this main point. Why is it main point? Because I said the point has been assigned at the top level. Now after that, I have created an object here. You need not look at the other lines. I will explain them one by one, but first of all, check the blank. This is an object which I created, and I created an object for the point class. Here you can see that I have created blank is equal to, then I have called the point class and used the parenthesis. So now blank becomes an object of the point class. Now here when I am printing blank, what it should return? I am running it, I will show you. You can see here, this is the answer or the output for the print blank. Here it says main.point object at this memory location. Now this means that blank is an object of the point class at this memory location. After that, what I have done is, as I showed you in the PDF, I am assigning an attribute blank.x equal to 3.0, another attribute blank.y equal to 4.0. Now what happens if I print blank.y? What should happen is, it should print the value which is 4.0. I already have run it. I will show you. You can see here, when I print blank.y, I get 4.0. Now after that, I explained you, I have taken a variable x and then I have assigned the value blank.x. Now what it will do is, it will actually store the value of this attribute blank.x, which is 3.0, into the variable x. Here, as I told you earlier, this x and this x do not clash with each other. They are totally different. Now when I am printing the x variable, this is actually referring, this x here is actually referring to the x variable. When I print x, what happens is, I am getting 3.0. For your convenience, I will run it once again. Here I am running it. You can see that this 3.0 is actually the value or the attribute blank.x, which has the value 3.0, and this is getting printed here. Now let me go back to the PDF. Here I will again tell you, the expression blank.x means go to the object blank refers to, where does the object blank refers to? It actually refers to the point class and get the value of x. Here what is the value of x? The value of x that we gave was 3.0 here. And then in the example, we assign that value to a variable named x, as we have done here. Now, as I say, there is no conflict between the variable x and the attribute x. Now, you can use dot notation as part of any expression. For example, I have this example here. Here you have %g, and %, then blank.x, blank.y. What does it do? It actually takes the value of blank.x and blank.y and prints it. So when I print it, I get this as the result. The values 3.0 and 4.0. Then here I have taken another variable distance, and here what I have done is, I have used the math module and used the function square root and calculated the distance. What is the formula for distance? Square root of x square plus y square. So when I am printing the distance, I am getting 5.0. What it means is, actually I will tell you, the square of 3 is 9 and the square of 4 is 16. So 9 plus 16 is 25. So when you take the square root of 25, the result is 5.0. So here you are getting this. This is a basic example where you can actually use the dot notation. Now let us move on to the next way. Now you can also pass an instance as an argument in the usual way. For example, here you can see that I have defined a function which is named print point, and I have passed the argument p. So what is this p? P is actually a point. P is the point object that we created just now. Now when we print %g, %d, then %p dot x, p dot y, what it should print is, it will also result in the same thing here. Here we have 3.0 and 4.0. This should also return the same thing. Now, we can call this function and then we can print the values of the attributes x and y. So here you can see that print point, then the argument passed here is actually the object blank that we created. Now you can see that the answer is 3.0 and 4.0. So what is the p here actually? The p here is actually an alias or other name for the blank object that we created. So if the function modifies p, blank also changes. Now this argument p will get modified here, and then at the same time it will also change the blank object. Let me show you in the PyCharm how it is actually happening. Here you can see that this is the function definition that I created. This is now outside the class because you cannot see any indentation here. Now when I create an object blank and tell that it is an object of the point class, then if I say blank dot x is equal to 3.0 and blank dot y is equal to 4.0. Now how can I call this function is the next question. I have to call this function. For that, just because it is not inside the class point, I can call it directly. I will show you how to call it. Here I can do this. I can say print point, then I can give the argument which is my object blank. Now if I run it, you can see that it is giving me the values 3 and 4. But the question is, here I have given 3.0 and 4.0, but in the answer when I'm running it, I'm getting 3 and 4. How is this happening? This is happening because of the %g and %g. What it does is, it actually takes floating point, double float or exponential values and then it converts it to a lesser value. Therefore, we are getting integer values here. So again, I will run it and show you. Here you can see I am getting 3 and 4. Now here I will tell you one thing. This blank actually is the object here which we created. This is the object, and when we are calling the print point function here, this p will actually get replaced by this blank. Now this argument now here will refer to the blank and it will make changes to the blank object. So this is about the print point function. Now what if I define this function inside the class? How can we call it now? I will show you how to do that. I will just delete it, and after this docstring I will press enter and then paste it. Now you can see that as soon as I have put the function definition inside the class, what happens is, now we cannot directly call this print point. You can see it has been highlighted by red color. That's why there is an error. Now how to call it is the question. We can call it by just using point and the dot. So that's it. In this way, when the function definition is inside the body of the class, then this is the way of calling it. Here what we have done is, we are using the point class, then using the dot operator. With the dot operator, we are calling the method or the function inside the body of the class. So then we are passing this argument. Now when I run it, you can see I'm getting the same answer as before. Now let us move on to the next topic, which is rectangles. So sometimes it is obvious what the attributes of an object should be, but other times you have to make certain decisions. For example, imagine you were designing a class to represent rectangles. So what are the attributes that you would use to specify the location and size of a rectangle? What you can do is, for the time being, you can ignore angle to keep things simple. Assume that the rectangle is either vertical or horizontal. So, in that case, there are two possibilities. First one is, you could specify one corner of the rectangle or the center, the width and the height. And the other one is, you could specify two opposing corners. In that way, you can actually specify the location and the size of a rectangle. But at this point, it is hard to say whether either is better than the other. So just to check that, we will implement the first one. Just an example. Here you can see this is the class rectangle. And in this I have the docstring which says it represents a rectangle, and the attributes of this rectangle class are width, height and object. So whatever object we create or instantiate in this class rectangle will have the attributes for the time being, which are width, height and the corner. So now, to create an object or instantiate a rectangle object, what can we do? I am taking this object as box is equal to rectangle. As I showed you in the point class, likewise in the box class, we can say box is equal to, then we can call the rectangle class and then use the parenthesis. Now this will create an object which is in the rectangle class. Now to define the attributes, I am giving box.width equal to 100, then box.height equal to 200, box.corner. Here the corner will actually be two coordinates. Therefore, we have to again use the point class in this case. Therefore, the box.corner will actually be another object of the point class. Here you can see box.corner is equal to point, which is the name of the class, and followed by parenthesis. Now, therefore, we have to assign the attributes of the box.corner variable, which is actually the attribute of again this rectangle, which is box. So what I have done is box.corner.x is equal to 0.0 and box.corner.y is equal to 0.0. Now by 0.0 and 0.0, what you can say that actually the rectangle, which is a box here, is actually starting from the origin, which has the coordinates 0, 0. Now here I will give you an overview. The expression box.corner.x means go to the object box refers to and select the attribute named corner. Then go to that object and select the attribute named x. This is what we mean by box.corner.x. Here, what will this command do? It will actually say go to point class and go to the attribute x and then assign the value 0.0. Here, go to the point class and go to the attribute y and assign the value 0.0. So likewise, what we have done is we have designed or assigned the attributes of the corner attribute to the coordinates 0 and 0. Now let me show you the state diagram, which is also known as the embedded diagram, because here one class has attributes which are embedded with another class. Here rectangle is one class and In this rectangle, the first object is the box, which has the attributes width, height and corner. Here the width is 100, the height is 200 and the corner has attributes which are the x and y coordinates, which have been assigned the values 0 and 0. So this is also called an embedded object because the object of one class has an attribute which is again an object of the different class, which is point in this case. Now, after you have known about the embedded diagram here, let us actually see how we can return values which are actually instances. So the next topic here is instances as return values. So now what can be done here is functions can return instances. For example, find center takes a rectangle as an argument and returns a point that contains the coordinates of the center of the rectangle. What I mean is, here I have defined a function named find center which takes an argument rect. The rect here actually refers to a rectangle, and then what it does is it actually returns a point that contains the coordinates of the center of the rectangle. Here you can see that I have taken a variable p which actually will be an object of the class point, and then I have defined the center. How I have done it is I have taken an attribute p.x and said equal to rect.corner.x plus rect.width divided by 2. Here what I have done is actually I am trying to find the center of the rectangle. Here what was the value of the rect.corner.x? In our earlier case it was 0 because the rectangle was starting from 0 or the origin. So the x and the y coordinates here will be 0 and 0. So what it will do is it will actually divide the width by 2, and in the second case in the p.y it will actually divide the height by 2. Then I am returning the point p. So here is an example how it is actually done. You can see here I have taken a variable center and I have called the find center, and then inside the parenthesis I have given the argument box. The box here is actually the rectangle which we created earlier. Now after that we are using the print function and printing the center variable. What it is doing is it is returning 50 and 100. So how are we getting 50 and 100 here? I will show you. Here we had the width as 100 and height as 200. Now you can see that we got 50 and 100. So the height got divided by 2 and the width got divided by 2. So we are getting 50 and 100. Now let me show you in PyCharm so that you can understand better. I have this example already written for you. Here this is the class point which we already had earlier, and then this is the docstring which says it represents a point in 2D space. Then I am using the print point function where I am taking the point or the argument which is p, which will actually refer to a point. Then what I am doing is I am printing the attributes x and y, which are the x and y coordinates. Then here after the class point I am creating another class which is the class rectangle. Here you can see the docstring which says it represents a rectangle. The attributes are width, height and corner. Then after that I am defining the function called find center. Then I am giving the argument rect. This here rect actually will take the box object which we will create in this example. But in my PDF representation, I have already told you how to create the object box, which is the rectangle of this rectangle class. Now here I have taken a point P is equal to an object of the point class. Here what I am doing is P dot x equal to, actually I am dividing the width by 2 and I am dividing the height by 2. So by dividing the width and the height by 2, we will actually be able to calculate or find the center of the rectangle. So now what I want to show you is what I have done here. Now this box equal to rectangle is the first object, which is the instant of the rectangle class. Now this process is known as instantiation, as I have told you already. Now I am defining the attributes here. Box dot width equal to 100, then box dot height equal to 200, and then box dot corner. As I told you earlier, the corner will be the x and y coordinates, therefore it will also be an object of the point class. So here the corner coordinates of x and y will be 0 and 0, as I showed you here. Here I have given the coordinates, the values 0.0 and 0.0. Therefore what we know is the rectangle is starting from the origin. But now because of this find center function, what we will be able to do is we will be able to find the center of the rectangle, which is box in our case. Now what I have done is I have created a variable called center, and then you can see here, if I call the function find center only by writing the name, I will delete this rectangle, and then you can see that I am getting an error just because the function definition is inside the body of the class. So this is wrong. What we can do is we can use the name of the class, then use the dot operator to use any functions which have been defined inside the class. So now if we call the rectangle dot find center, then give the argument as our box rectangle. Now after creating the center variable, what I did was I showed you how to call the function find center by giving the argument box, and after that I am actually trying to call the print point function, which is actually inside the class point. So this print point function, what it will do is it will print the coordinates of any point. So here in this case I want to know the coordinates of the point center. How I can do that is I will call the point class and then I will use the print point function, and in that I will give the argument as my center variable here. Now if I run my program, here you can see that I am getting 50 and 100. So I will show you what happens. In this function, I divided my width by 2 and then I divided my height by 2. So what happens is when I divide my width by 2, I get 50, and when I divide my height by 2, I get 200. So here, that's why when I run my program, I am getting the answer as 50 and 100. So width becomes 50 and the height becomes 100 because it has been divided by 2. Now let me go back to the PDF. Here I will show you the next subtopic, which says objects are mutable. Here, as we saw in lists, dictionaries and tuples in module 2, here in module 3 I am talking about objects and I am telling that objects are mutable. So what is the meaning of mutable? The mutable meaning means the values of the objects or the object's attributes can be changed. How can we do that? I will show you in a moment. So here you can change the state of an object by making an assignment to one of its attributes. For example, to change the size of a rectangle without changing its position, what we can do is we can modify the values of the width and height. So in that case, it will not change its position, it will only change its height and the width. So I hope you were getting it, because the location of the corner point will be stable. It will stay at the origin. But what we are only doing is we are trying to grow the rectangle in size. How can we do that? We can increase the width and the height. So by that we will not be changing the position of the rectangle. We will only be changing the size. We can either reduce the size or we can either increase the size. In our case, we will just see how to increase the size of the rectangle. So I have defined, here you can see I have a function definition which says grow rectangle, and then here it is taking the three arguments which are the rectangle, the width and the height. So these are the three arguments that this function is taking. Then what I am doing is I am changing the width and the height by using the augmented operators. Here I am using the augmented increment operators. So this rect.width will be incremented by these values which we provide, d width and the d height. So here the meaning is rect.width is equal to rect.width plus d width. The d width will be taken from this value, and in the same way rect.height is equal to rect.height plus d height. So the d height will be taken from this d height value. So the initial width and the initial height will be incremented by these values we are assigning as parameters here. So here is the example. Here in the earlier case, what was done was the width of the box was increased by 50. So I will show you what happens actually. Here the width was 100 and the height was 200. Just remember it. Now I am going here to our topic. So it was 100, so it will be 150, and the box height will be 100 plus 100, it will be 200. So let me show you how to do that in PyCharm. I will go to my PyCharm. I will minimize this, and here I have, you can see I have used the function grow rectangle, which takes three arguments: the rectangle, the width and the height. These are the three arguments or the parameters which are given here. Now when I call the function which is the grow rectangle, how I can call it? I have to call it using the name of the class, which is rectangle. Then I have to use the dot operator, and then as you can see I am getting the grow rectangle option here. This is the option. Now I will press enter and it will take three arguments. You can see it's highlighting rectangle. So here in this case my rectangle is box, and then it will take two more arguments, the d width and the d height. So in my case the width is 100. If I want to increase it by 50, what I can do is I can give 50, and then in my case the height of the box is 200 and I want to increase it by 100 so that I can grow the size of my rectangle. So if I give this required arguments and then if I run my program, I will show you, I'm running it. You can see you won't be able to find what actually happened. But now if I print the values of this width and the height, then you will know or you will notice what actually happened. I will actually print the values of my box dot width and the box dot height. Then you will understand what actually happened. Earlier you can see here the width was 100 and the height was 200. Now I am running it. you can see what happened. I gave the arguments 50 and 100. So 50 was referring to this the width. The width was 100. So when I ran it, I got 150, and here the height was 200, and when I ran it, I got this 300. So this is how you can grow the size of your rectangle by using this function without actually changing the location of the rectangle. The next subtopic here is copying. So, aliasing can make a program difficult to read because changes in one place might have unexpected effects in another place. It is hard to keep track of all the variables that might actually refer to a given object. So, instead of aliasing, copying an object is often an alternative which is better than aliasing. The copy module provided by Python contains a function called copy that actually duplicates an object. So in this way, we can create the duplicate of any object, and if we make changes to the new object, it will not have any effect in the other object. So here, what I want to say is I have created a point called P1, which is an object of the point class. Now I am defining the attributes p1.x equal to 3.0 and p1.y equal to 4.0, and then I am importing the copy module, and I am taking another object p2 and I am using the copy.copy function, and what I am copying is I am copying the attributes of the p1 object. Now here you can see that p1 and p2 actually contain the same data, but they are not the same point. They are actually two different objects. Now when I print point p1, then what happens is I get 3, 4 because the attributes value were 3 and 4. Again, if I print point p2, again I will get the values 3 and 4. But when I check with the is operator, if p1 is equal to p2, then I am getting false. And in the second case also, when I am checking with the comparison operator double equal to p1 equal to p2, then also when I check, I get false. So here the is operator indicates that p1 and p2 are not the same object, which is what we expected, because in object-oriented programming, if we create one object and then create another object, both will have the different references. Therefore, the object p1 and p2 will not be the same, even though we have copied the properties of the object p1 to the object p2. But then also the objects p1 and p2 are exactly different. But when we use the equal sign, we might have expected to yield true because these points contain the same data. Here you can see when I actually tried to use the comparison operator equal and check p1 equal to p2, then also we got false. But it is really confusing because we have 3, 4 when we print the point p2, and again when we print the point p1 we get 3, 4. So in this case we should have got equal, but it is not that. In this case, you will actually be disappointed to learn that for instances, the default behavior of the equal operator is the same as the is operator. The is operator also checks whether p1 and p2 are same, and the equal operator also checks if p1 and p2 are the same objects. But in this case, both are referring to different objects. Therefore, in both the cases, we get false. And here, the equal operator actually checks object identity, not the values inside the objects. It checks whether they are referring to the same object or not. So, the reason behind that is because for programmer defined types, Python still doesn't know what should be considered equivalent. So it considers that the P1 and P2 are two different objects. Now, if we use copy.copy to duplicate a rectangle, you will find that it copies the rectangle object but not the embedded point. Now I will show you what I mean actually. Here I have, in my earlier example, I created a box. Here I am creating a box 2 is equal to copy.copy of the earlier rectangle box. And then if I am checking box 2 is box, it says false because box 2 and box are not referring to the same object. Box 2 is a different object and box is a different object. But here when I am checking box2.corner is box.corner, what it means is the attributes of the corner coordinates x and y for both box 2 and box, the rectangles, is absolutely the same. That's why I am getting true here. I will show you with the help of the diagram what this actually copy.copy means. The copy.copy is actually known as the shallow copy. Here you can see this operation is called shallow copy because it copies the object and any references it contains, but it does not copy the embedded objects. So this is the meaning of shallow copy. Here it copies the object and any references it contains, but it does not copy the embedded objects. That means box 2 and the earlier box rectangles are totally different. Now this is the diagram here. Here you can see this box is a different rectangle. This box 2 is a different rectangle we created. The box has attributes width, height and corner, and the box 2, just because I used the copy.copy function, therefore I got the width as 100 and the height as 200. So these values are similar. But here in the corner, these two are referring to the same attribute, which is the y attribute of this point. Because here we are using the shallow copy. Here these two are actually different objects, but the corner attribute in both the cases will be referring to the y attribute, which is of the point class. Therefore, as I showed you here, box2.corner is box.corner. It means that they are referencing to the same attribute. Therefore, I am getting true. Now, after this example, I will show you how to run it in PyCharm. Here, I already have the class point written here. Then I have taken the definition, which is print point. This will print the coordinates x and y. After that, I have created the object P1, which is of the point class. Then I have assigned the attributes of the x and y coordinates. The x coordinate is 3.0, the y coordinate is 4.0. Here you can see I have imported the copy module, and then I have created another object P2 as I showed you in the example, and then I have used the copy.copy function, and what I have done is I have copied the values or the attributes of P1 object and copied them into P2 variable. So now P2 and P1 have the same values. How? I will show you how. I will just run this program, and here you can see that here I used point.printPoint for P1 and it said 3, 4. And here when I print the same thing for P2, it also says 3, 4. But when I am using the is operator and checking if P1 is P2, then I am getting false because P1 and P2 are totally different objects here. And in the same case, the is operation is also done by this equal, which is the comparison operator. And when I am checking with this also, I am getting false because P1 and P2 are referring to different objects here. They only have the same values, but they do not point to the same object. Now let me go to the other example, which was the rectangle. Here I already explained you about how to use this point and the rectangle class, and I showed you how to grow the rectangle in the earlier example. Now I will show you how to actually use the copy function in case of this rectangle. I have already written it out. I will just delete these quotes and I will show you properly. So now you can see that after I created the first box object, then I am importing the copy module, and then I am creating a new variable which is box2. This is another rectangle, and then I am using the copy.copy, and then I am copying the attributes of the box, the earlier rectangle, which is here. Then now what I am doing is I am printing box2 is box. So first of all, let me just comment these things so that you don't get confused. Now I will show you what actually I am trying to do. Here I said I copied the contents of the box rectangle into the box2. Then I am using print function and checking if box2 is box, whether box2 and box refer to the same object. And then again I am checking box2.corner is box.corner. So if I run this, you can see that here I am checking box2 is box and I am getting false because box2 and box are totally different objects. But as I showed you in the diagram here, the corner attributes for both the boxes or both the rectangles is the same, which is of the point class. Therefore, when I check with this, box2.corner is box.corner, they are referring to the same attributes. Therefore, I am getting the answer as true here. So this is about the copy.copy method or the copy.copy function. So now you have understood about the copy.copy method, but what is the problem in this? So for most applications, this is not what you want. So in the example I showed you here, what we were doing was we were trying to increase the height and the width of the rectangle so that we can increase the size of the rectangle. Or you can also write a function where you can decrease the size of a rectangle. You just have to use the minus symbol here. So, but the problem here is that when we try to copy the attributes of the object box and then we change it to the box 2, what happens is, so here we are actually copying the content of the box to the box 2 object. So what happens is, in this case, when we use the grow rectangle function, it will not create any difference. If we use the grow rectangle function for the box, it will not reflect any changes in the box 2. But if we had another program where we might have defined anything like move rectangle, then what would happen is, if we move the location of the box or the first rectangle, it will also make changes in the second rectangle, that is the box 2. So we do not want this. For that, what can we do is, we can use the deep copy method, which I will show you here. This is the deep copy method. I will just remove the hashtags so that I can actually highlight the program code. Now you can see that I have a box 3 and here I am using the copy.deepCopy function and giving the argument as a rectangle box which we created earlier. Then if I print box 3 is box, you will be very interested to know what is the output. Let me just run it. You can see that here when I print box 3 is box, it says false. But in the earlier case, when I printed box2.corner is box.corner, then just because they were referring to the point class and the y attribute, here we got true. But in the deep copy case, what is happening is when I try to print box3.corner is box.corner, then here I am getting false. This means now the box3 and the box are totally different objects and they have the attributes which are also totally different. So here what does the deep copy function do? The deep copy function copies the contents of an object and also copies the attributes or embedded objects which are connected to the first object to the second object. So in this case, if we modify the content or the attributes of any one object, say box, then it will not make changes to the content or the embedded objects of the box 3. So this is the feature provided by Python with the help of which we can make changes to any one object so that it doesn't reflect into the other objects which we created by using the deep copy method. So let me take you to the next topic, which is debugging. So when you start working with objects, you are likely to encounter some new exceptions or errors. If you try to access an attribute that does not exist, you get an attribute error. I will show you how. I have created an object P, which is an object of the point class. Then I have assigned the attributes p.x equal to 3 and p.y equal to 4. And now if I try to check an attribute which does not belong to the object, say p.z, then I will encounter this attribute error. It says point instance has no attribute z. I will show you with an example, but let me clear the theory part here. So if you are not sure what type an object is, you can just type P in brackets. So you will know what actually this object type is. It will say class main and it will give you the name of the class which it belongs to. You can see here class main and then point. Also you can use isInstance to check whether an object is an instance of any particular class. Here you can see isInstance. It takes two arguments. The first argument is the object and the second argument will be the name of the class. If this P object is actually an instance of this point class, then we will be getting true. But in other cases, if you are not sure whether an object has a particular attribute, you can use the built-in function hasAttr, which actually says has attribute. How to do that? I will show you here. You can say has at attr and then p comma under the string you can define the attribute. So p is the object and in between the strings this is the attribute. So if the object p has the attribute x, then you will get true, or else if it doesn't have the attribute x, say in this case I gave z, it says false. So here the first argument can be any object, the second argument is a string that contains the name of the attribute. So let me show you in PyCharm so that you will get a pictorial idea of what is actually happening. Here I have the class point and then I have defined a point object which is p, which belongs to the class point. Therefore, and then I have assigned the attributes p.x equal to 3 and p.y is equal to 4. Now if I try to do this thing, if I try to print p.z, what happens is when I run this, you get attribute error. It says point object has no attribute z. the object P here does not have any attribute by the name of Z because it only has the attributes X and Y. Therefore, you cannot define or you cannot print P dot Z. Again, I will show you the other ones. As I told you, if I print is instance, what are the arguments it takes? The first argument will be the object P, and if it is an instance of the class point, enter. And then if I run this, I will just comment it out for you. And if I run this now, it says true. That means the object P is actually an instance of the point class. So that's why we are getting true. Now, if you are confused, then you can also do this. You can check the type of an object. So print, and after that you can say type of the object P. And now if you run it, I will comment this out. Now if you run it, you can see the type of P is that it is actually an object of the class point. And I will show you the other one now. I will just comment it out. And you can check if an object has any attribute by this. I will print and say has attribute, and it will have two arguments. First is the name of the object, which is P in our case, and then in between strings I will take the attribute. In this case it is X. I will check with the genuine ones now. I will run it, and you can see the object P has the attribute X. That's why we are getting true. Now if you change it to Y also, you should get it true. And I'm running it again. In this case also we are getting true. But in the third case, if I give some attribute which is not present in the object, say I'm giving Z, and if I run it, I'm getting false. It says the attribute Z does not belong to the object P. So this is how you can check with the use of is instance, type, and has attribute. Now let us move on to the next chapter, which is classes and functions. Here let us move on to the first topic, which is time. Here we will create another example of a programmer defined type, which is time that records the time of a day. The class definition looks like this. Here you can see this is a class time, and this is the doc string which says it represents the time of day, and the attributes are hour, minute, and second. Now we can create a new time object and assign attributes for hours, minutes, and seconds. Here is the object. You can see here time is the object which is from the class time. You can see T is in capitals and parenthesis is given. So here we are instantiating an object or creating an object time, which belongs to the time class. Here these are the attributes: time.r equal to 11, time.minute equal to 59, and time.second equal to 30. So the state diagram for this will look something like this. Here this is the time class, and this is the object time which has been instantiated, and these are the attributes: hour equal to 11, minute equal to 59, and second equal to 30. So let me show you in PyCharm how you can do this. I have already written the program for you. Here you can see this is the class time, and this is the doc string which says represents the time of day and the attributes are hour, minute and second. Now here I have defined a function called print time and it takes the argument time. So this argument will directly refer to this object when we call the function print time. Here I have returned time.hour, time.minute and time.second. So when this function is called, it will return the time in hours, minutes and seconds. Here you can see I have created a first object which is time, which belongs to the time class, and here I have set the attributes to 11 hours, 59 minutes and 30 seconds. Now here you can see if I remove this time dot, now if I print this, I will not be able to do this because it has been highlighted by red lines. So this means there is an error because the print time function is in the body of the class. Therefore, to call it, we have to use the name of the class. So time dot print time. This is how you call this function inside the class. Now if I run this, I should get the time in hours, minutes and seconds. It should be 11 hours, 59 minutes and 30 seconds. I will run this. Here you can see this takes an argument, but I have not given any argument here because in the function there was an argument time, so it should be the object time here. Because I did not give this, I am getting an error. Now I will provide the argument which is my time object. Now if I run this again, I am getting the exact time, 11 hours, 59 minutes and 30 seconds. So this is how you can create a class called time, and here this is the print time function which returns the time in hours, minutes and seconds. Here I created the object time and assigned the attributes hours, minutes and seconds. Then I used the print time function by calling the time class, and then when I was running it, I got the exact time. So this is about the time class. Let us move on to the next topic, which is pure functions. Here I have defined a function which is called addTime, which takes two arguments t1 and t2. t1 and t2 are two objects which actually here represent the start time and the end time of, say, a movie. Here what I am doing is I am defining a variable called sum which actually represents the object of the time class. Why I am doing this is that I have to do some operations to this sum object. Here I will show you what I am doing. Here I have taken the attributes sum.r is equal to the t1.r and the t2.r. This will be the attributes of the two arguments. So what I am trying to do is I am trying to add the duration of the start time and the duration of the end time. So how I will do it is I am doing it by using this sum.hour equal to t1.r plus t2.r. Then in the same way I am writing sum.minute equal to t1.minute plus t2.minute. In the same way for the seconds, sum.second is equal to t1.second plus t2.second. And then finally I am returning the sum object. So here let me explain what actually this addTime function is doing. The function creates a new time object, initializes its attributes and returns a reference to the new object. This is called pure function because it does not modify any of the objects passed to it as arguments, and it has no effect like displaying a value or getting user input other than returning a value. So it does not modify any objects, it just returns a value. So here with this add time function, I am trying to determine the total time consumed during the start of a movie, say movie, and the end of a movie. So what I am trying to do is I am trying to calculate the total duration. So here, as you can see here, let the movie name be Monty Python and the Holy Grail, and start will contain the start time of a movie and duration contains the runtime of the movie, so which is 1 hour and 35 minutes. So here you can see I have created an object start is equal to time class. This object will belong to the time class, and then I have defined the attributes start.r equal to 9, start.minute equal to 45, and start.second equal to 0. So here the movie here starts at 9 hours and 45 minutes. And then I have taken another object which is duration, which belongs to the time class. Here I have also defined the attributes which are duration.r equal to 1, duration.minute equal to 35, and duration.second equal to 0. Here it means that the total duration of the movie was 1 hour and 35 minutes. Then I am again creating another object done which calls the add time function, and it has two arguments, start and duration. So when I run this code and then print the done object, it should return the total time, which is 10, 80 and 00. So here I will show you in PyCharm what actually I am trying to do. Here you can see this was the earlier class time where I defined print time, which actually returned the time in hours, minutes and seconds. As you saw in the earlier example, we had created the object time and set the attributes hours, minutes and seconds. Then when we printed the time, it displayed the time as 11 hours, 59 minutes and 30 seconds. I will run it for you once again so that you can remember. Here you can see the time was totally 11 hours, 59 minutes and 30 seconds. So now let me show you how to do this by pure functions. Here I have already written the code for you. Here this is the class time, and here is the print time definition from the earlier example. It returns the time in hours, minutes and seconds. And then here you can see this is the add time function which takes two arguments t1 and t2. These are the start and the duration, and then I have instantiated an object called sum which belongs to the time class. And then what I am doing is I am trying to add the hours from the two objects and add the minutes from the two objects and add the seconds from the two objects, and finally I am returning the variable or the object sum. And then here you can see this start is the first object which belongs to the time class. These are the attributes. It has 9 hours, 45 minutes and 0 seconds. Then duration is the second object of the time class. The attributes of duration are 1 hours, 35 minutes and 0 seconds. What actually is this duration object? This is actually the time duration of the movie I was talking about. Now here I have taken the third object done, and here you can see I am calling the time class so that I can use the dot method to call this add time function. Here I am giving the arguments start and duration. These are the two objects which are taken as arguments in this function, and then I will print the time of the done object. Let me run this for you. I am running it. Here you can see that the actual duration was 10 hours and 80 minutes. But don't you think that it is not giving us the correct output, because we don't have 80 minutes, because as soon as it reached 60 minutes, it should have incremented the hour value to 11 hours, and then the rest of the 20 minutes should have been displayed here. For that, what I can do is, I will show you how to do it. Here, let me go back to the exercise or the PDF. Here you can see that the result 10 minutes, 10 hours and 80 minutes might not be what you were hoping for. The problem is that this function does not deal with cases where the number of seconds or minutes adds up to more than 60. So when that happens, we have to carry the extra seconds into the minutes column or the extra minutes into the hour column. So as soon as the seconds is more than 60, it should get incremented in the minutes value, and as soon as the minutes is 60, it should get incremented in the hours value. So for that, here is an improved version. So here what happens, I am using the if statement here. So if the sum dot second is greater than 60, what I am doing is I am subtracting it from the sum dot second by 60. So, and then I am incrementing the sum dot minute by 1. So as soon as the value of sum dot second becomes more than 60, the minute value will be incremented by 1. And in the same way, when the minute value becomes more than 60, it should be subtracted from 60, and as well the sum dot hour will be incremented by 1. So I will tell you in brief what is actually happening. As soon as the seconds become more than 60, it should be subtracted from the seconds value, and the rest of it should be incremented to the minutes value. And as soon as the minutes become more than 60, it should be subtracted from the minutes, and the hour value should be incremented by 1. Then finally we have the return sum. So I think this will solve our problem. Let us go to PyCharm and check it. Here I have to write this code after this. So after this I have to use this if statement. Here you can see I have used the if statement, and what it will do is, as soon as the second becomes more than 60, it should increment into the minute, and as soon as the minute becomes more than 60, it should increment the hour. Then I am returning the sum. So let's see if it solves our problem or not. I will run the program again. You can see earlier it was printing 10 hours and 80 minutes. Now it is correctly printing 11 hours and 20 minutes. So this is how you can actually correct the problem in this code. After pure functions, let us move on to the next topic, which is modifiers. So sometimes it is useful for a function to modify the objects it gets as parameters. In that case, the changes are visible to the caller. Functions that work this way are called modifiers. So what are modifiers actually? Modifiers modify the objects it get as parameters. That's why they are known as modifiers. Here is an example of a function called increment, which adds a given number of seconds to a time object, and it can be written naturally as a modifier. So here is a brief draft of the example. Here you can see the definition of the increment method or the modifier. Here the increment method takes two arguments, the time and the seconds, and then what does it do? In the time object, it adds the seconds argument to the time dot seconds attribute. So after that, we are checking if the time dot seconds is greater than equal to 60, then this seconds value will be subtracted from the time dot second attribute. After that, as soon as it is subtracted, the time dot minute attribute will be incremented by 1 because the value of minutes exceeded 60. And after that, if the time dot minute value exceeds 60, then the time dot minute value will be subtracted from 60, and finally the time dot hour value or the attribute will be incremented by 1. So let me show you in PyCharm the time class so that you can understand better. Here is the time class, and here you can see the increment method or the modifier. It takes two arguments, time and seconds, and I already explained you this thing. When the seconds is more than 60, it will be subtracted from the time dot second attribute, and the time dot minute attribute will be incremented by 1. And finally, if the time dot minute attribute is more than 60, then it will be subtracted from 60, and finally the time dot hour attribute will be incremented by 1. Then I am returning the time dot hour, time dot minute and the time dot second attributes. Here you can see I have taken or instantiated an object t1 in the time class, and I have defined the attributes. You can see here the t1 dot hour is 9, the t1 dot minute is 45, and the t1 dot second is 60. So here after that I am calling the increment method in this line. Here you can see I am calling the increment method by calling the time class and then using the dot operator and then using the name of the method increment. Here I am passing two attributes. The first one is the object, which is t1, which I created just now, and then second attribute is seconds, which is 30. So in this case what should happen is the t1 dot second is actually 60, so 60 plus 30 should be 90. Therefore as soon as 60 plus 30 becomes 90, the minute attribute should increment by 1 and become 46, and the hour attribute will be as it is because it is less than, because the minute attribute is less than 60. So let me run it for you so that you can get a better idea. I'm running it. Here you can see I gave seconds equal to 30. So 30 plus 60 was 90. Therefore 60 will be subtracted from 90 and we get 30 in the seconds attribute, and finally the minute attribute will be incremented by 1, so 45 becomes 46 here, and the hour attribute remains as it is. So this is an example of a modifier which actually takes an object as an argument and modifies the values or the attributes inside the object. Now let us move on to the next topic, which is prototyping versus planning. So as we saw in the earlier programs, we defined a time class where we set the attributes hours, minutes and seconds, and then we defined a function called print time where we were able to print the time as we defined objects. So as we started printing the time, we encountered certain problems. What were the problems? The problems were when we tried to find the value of minutes which was more than 60, then we got wrong outputs. So I will tell you one example. We got 10 hours and 80 minutes. Actually the answer should have been 11 hours and 20 minutes. So this is actually prototyping versus planning. As we start with some programs and define them in the class and use functions to get values, we will be coming across various problems. I already told you about the problems. The problems can be depending on the minutes which we have to convert them to hours, or it can be the seconds which we have to convert to minutes, and so on. So as long as we go on coming across problems, we have to do some kind of planning. So the prototyping plan can be effective, especially if you don't yet have a deep understanding of the problem. But incremental corrections can generate code that is unnecessarily complicated. As you saw in the programs we wrote, we encountered problems and we kept on tackling those, but it made our problems larger and larger. And then what happened, as we tried to solve the problems, the program code has become very long. So an alternative is the design development, in which high level insight into the problem can make the programming much easier. So let us see an example here. Here is a function that converts times to integers. So this is the definition of the function. Define time to int time. What this function will do is, it will actually convert the minutes to seconds, and the seconds will get the seconds from the minutes variable, and it will then add it to the additional minutes stored in the seconds. Then it will return the value of the seconds. And finally, here is another function that converts the integer to a time. So here what I want to say is, you might be having a certain value, say 1000 seconds. These again needs to be converted to time. So how to do that? Here this function does this. The into time function takes the argument as seconds. Then here the time object is called or instantiated, which belongs to the time class. And here I am using the div mode, which is a built-in method or a function which actually divides the seconds by 60, and it sends the value of the quotient to the minutes attribute and sends the value of the remainder to the time.second attribute. In the same way, this div mode here actually sends the quotient to the time.r and sends the remainder to the time.minute, and then finally the actual time which has been calculated by the function will be returned. So here you might have to think a bit, and you also have to run some tests to convince yourself that these functions are correct. One way to test them is to check that the time to int function is correct by taking many values of x and calculating the result. If you think that the output is okay, then you can go on and use this function. So this is an example of consistency check. And then finally, when you are convinced that your function is working properly, you can then define the add time, and here you can give the two variables, the start and the duration. Then you can calculate the exact time. Here what happens is, it takes the seconds variable and it sends the seconds to this time to int, which is defined here, and it actually converts the minutes to seconds and then the seconds to further seconds and returns the seconds. And finally again it converts the second argument and then takes it to this function again, and finally it also returns the value of seconds. And here all the values that is accumulated in this seconds variable is returned to the into time seconds. So what happens here is, the seconds values will be taken to this into time, which actually converts the integer value in seconds to time. So I already explained you about this. Let me show you how to do this in PyCharm. So what is the benefit of this method of prototyping versus planning? The benefit is that this version is shorter than the original and easier to verify. So let us go to PyCharm. Here I will show you from the beginning. Here we defined a class time, and then we defined a function which actually printed the attributes hours, minutes and seconds. And when we started to deal with complexities, here I will show you by running this program. I am running it. You can see when we provide the inputs in standard order, then we get the output without any difficulty. I am getting 11 hours, 59 minutes and 30 seconds. But as soon as we go to the other examples, say pure functions, here when I give values like 9 hours, 45 minutes and 0 seconds, then again 1 hour, 35 minutes and 0 seconds, and then try to calculate the duration, and then I got certain results. I will show you. I got 10 hours and 80 minutes, which was wrong. But after that, we calculated using this if statements, and finally we were able to solve the problem. But what it did was, it was making our code longer and longer. That's why planning is very important to make your program code shorter, and also at the same time to make debugging easier, and also to make your program more productive and efficient. So here I will run this program for you as well. I am running it. You can see after solving everything, we got 11 hours, 20 minutes and 00 seconds. Finally, let us go to this prototyping versus planning Python file, where I have described everything in detail for you. Here, this is the class time, and here we have the print time function, and here I am using the time to int, where the minutes are converted to seconds and then the seconds is returned, and then finally I am using the into time, which actually converts the seconds value in integers to a particular time. Then I am returning the time, and finally here I am using the add time, where I am actually calculating the seconds by calling these two functions here, and then I am returning the seconds to this into time, so that I can calculate the particular value of the hours, minutes and seconds. So here this is called perfect planning, so that you can make the code shorter and efficient and save your time. Here I have the earlier values only. So here when I try to find the duration by taking another third object, which is done, and then if I try to print the time of the object done, I will show you what happens. I am running my program. When I run it here, I get the same value, which is 11 hours, 20 minutes and 00 seconds. So here I will show you, this is the normal time class with the normal print function, and then we went on to pure functions, where we started dealing with problems that we come across while solving the time related queries. And finally here is the prototyping versus planning, where we actually make the program shorter by defining two more functions which actually convert the minutes to seconds, and then the seconds variable is taken to the into time, and here the particular time is returned. So then finally I am using the add time, where I am calculating the duration from 9:45 here to 1:35. So when I run this, I am getting the result as 11 hours, 20 minutes and 0 seconds. So you can see the difference here. See the code length here, and finally the code length here has reduced because of this planning here. So this is about prototyping and planning. Now let us move on to the next topic, which is debugging. So how do we know that the object created has the correct attributes for minutes, hours or seconds? We can do that by debugging. Here I have created a function which checks if the time input given is valid or not. What I am doing here is, it is checking, you can see here, by the if statement. Let us see what happens here. You can see if time.hour is less than 0 or time.minute is less than 0 or time.second is less than 0, then return false. That means if the values provided in the hours, minutes or the seconds is less than 0, say a negative value, then this function will return false. And here if the minutes provided or the seconds provided is more than 60, in this case also it will return false. Otherwise it will return true. So with the help of this function we can actually tell that whether the time provided input is valid or not. And then after that we can define the addTime function, which takes two arguments, which are the start and the end time. Then here we can use this. If not valid time or not valid time, here T1 and T2, which are the start and the end, then we are using the raise value error. It will print invalid time object in addTime. Otherwise, if the values are absolutely correct, then we are returning the seconds to the earlier functions which I showed you. Then finally the seconds values will be returned to the function where the total integer value of the seconds will be converted to time. Or you could use an assert statement which checks a given invariant and raises an exception if it fails. What does it mean is, so we are asserting if the arguments T1 and T2 are valid. If they are not valid, then we will tell that the arguments T1 and T2 provided by the objects are not valid. Then this function will not work. Otherwise, if the arguments are valid, then it will work in a normal way. So let us see this in PyCharm so that you can understand better. I'm going to my PyCharm. Here you can see that I have created a Python file called debugging, and here after this conversion of seconds here in this function, and after the conversion of the integer value of seconds into a particular time, then I am defining the addTime function and I am returning the time to this function. And after that I am using the valid time function where I am checking if the values of the hours and the minutes or the seconds are less than 0, then I will return false. Otherwise, if the values of the minutes or the seconds is greater than 60, then also it will return false. But in normal conditions, when the values are true or correct, then it will return true. So here, after that, I am using the define addTime where I am checking if the arguments are valid or not, and finally if they are not valid, it will raise a value error saying invalid time object in add time. Otherwise it will carry on in a normal way and calculate the time. So I have the same values here. I will just show you how to check the output. I will run this, and here you can see it gives me the same result. But if I change the values here, if I try to manipulate the attributes, say if I give the minutes value more than 60, say 67, then if I run my program again, I'm running it, you can see that it has a value error and it prints invalid time object in add time. So here, because I have given a value of minute which is more than 60, it is raising this value error. But if I change it to the earlier value, which was 45, then if I run my program again, it will produce the same result. Now I will show you if I take some negative values, if I say -1, and if I run my program, in this case also it is producing a value error. So you can see how we can check if the time is valid or not. This is actually a very good way of debugging your program. Here you can check if the object created by an user is actually valid or not. Now you saw how to use the valid time to check whether the time is valid or not. Then after that, I will show you how to use this assert statement so that you can assert the arguments t1 and t2. I will go to my PyCharm again, and here I have already written it for you. You can see here we are asserting the t1 and t2 arguments and checking it by sending them to the valid time function. And then if I run this program again, you can see that it creates an assertion error because the value of the start hour is -1. Now if I change it to say 1 and run it again, you can see that I am getting certain amount of value. I changed it, it was earlier 11. I will change it to the earlier value, say 9. Then if I run my program, I am getting the perfect answer which I was getting earlier. So this is how you can actually debug your program and check if the input given by the user is valid or not. The input in this case will be actually the attributes of the object. So this is about debugging. Now let us move on to the next chapter, which is classes and methods. So here the first topic is object-oriented features. Let me give you an overview of this object-oriented features. Here Python is an object-oriented programming language, which means that it provides features that support object-oriented programming, which has 3 defining characteristics. The 3 defining characteristics are: programs include class and method definitions, and the second one is most of the computation is expressed in terms of operations on objects. Here objects often represent things in the real world and methods often correspond to the way things in the real world interact. So now let us move on and understand what are methods. Methods are semantically the same as functions, but there are 2 syntactic differences. Now, what I mean is methods and functions have syntactical differences. the way we write them in syntax is different. So let us start with knowing more about methods. Methods are defined inside a class definition in order to make the relationship between the class and the method explicit, and the syntax for invoking a method is different from the syntax for calling a function. Now let us see the next topic here, which is printing objects, by which you will understand more about methods and objects. Here I will again tell you about the time class which we created in our earlier topics. Here is the class time, and this is the docstring which says that it represents the time of day. And then I have defined the function print time, which will actually print the time in hours, minutes and seconds. So in order to call this function, you have to pass a time object as an argument. Here you can see the start here is an object which has been passed to the time argument. It means that start is now an object of the class time. So these are the attributes: start hour equal to 9, start.minute equal to 45 and start.second equal to 00. So when I print time and use the argument start, it will print the hours, minutes and seconds in this format: 9 hours, 45 minutes and 00 seconds. So I will show you this thing in PyCharm. Here you can see this is the class time, and here this is the function or the method which is actually returning the time in hours, minutes and seconds. But if I bring the function outside the body of the class, here if I do it, then what it does is it actually does not now belong to the class. It is outside the class. So now it is a function actually. But again, if I put it inside the body of the class, now this becomes a method of this class time. And so here you can see I have taken an object which is start, and this is an object of the time class, and then these are the attributes of the hours, minutes and seconds, which are given values 11, 59 and 30. So now there are two calling conventions to call this print time method inside the class. The first calling convention is like this. I will just remove this hash so that you can see it clearly. In this one, you have to write the name of the class and then use the dot operator, and then you have to write the name of the method, and in the brackets you have to give the argument as the object here. So this is one way of calling the method inside a class. Now if I run my program, you can see it displays the time in hours, minutes and seconds. And in the second way to call the method inside a class, I will show you how it is done. I will remove this hash, and here you can see this is the other way. This way starts with the object, and then using the dot operator you can call the method print time. So here in this line of code also, when I run it, it will also give you the same output. I will run it for you so that you can see the output for both the cases. I am running it now. Now you can see that the same output is given for both the print statements. So this is how you can call a method inside a class. Now I will go back to the PDF and show you what I just told you. Here you can see this is the class time, and this is the definition of the print time method, and this is the calling convention. I showed two ways. Here are the two ways. The first one is you have to use the name of the class and then use the dot operator and then write the name of the method, and it follows the name of the object in parenthesis. The other way is to write the name of the object and then use the dot operator and then call the function inside the class or the method inside the class, to be precise. So these are the two methods to call the method defined inside the class. I showed you here in PyCharm. These are the two methods. The first one is you have to write the name of the class and then use the dot operator and then call the method, and then in the brackets you have to give the name of the argument, which is the object you created. The second one is you can start with the name of the object, use the dot operator and then call the method inside the class. So now in object oriented programming, by convention the first parameter of a method is called self. So it would be more common to write print time like this. Here, this is the way object oriented programming codes are written in Python. This is the class time and this is the definition of the print time method, and here you can see the first parameter is self by default, and it is also doing the same thing. It is printing the time in hours, minutes and seconds, but the syntax is a little different. You have to write self.hour, self.minute and self.second. So here the first argument or the first parameter is self. So the reason behind this convention is an implicit metaphor. So here what we can say that if the function was outside the class, then it is very easy to call it with the help of predefined parameters. But when the method is inside the class, then we have to use the default argument or the parameter, which is self. So let me go to PyCharm and change my program in such a way that you can understand better. Here I will remove this time and I will write self, and here in all the three I have to change it to self. I will change all of it. Now you can see it has become self.hour, self.minute and self.second. Now in the same way, if I now run my program, it will also give you the same output. I will run it for you. You can see. So this is the basic convention of writing an object-oriented programming code in Python. Here the first argument in the function is self. So this self will refer to the object which is passed inside this function. So when I run it, the self becomes start, and that's why we are getting the return statement, and it is printing the attributes hour, minute and second. That's why we are getting this output. So this is how the conventional parameter or argument self is used in object oriented programming as the first argument in the definition of a method. So let us now move on to the next topic, which is operator overloading. So by defining other special methods, you can specify the behavior of operators on programmer defined types or classes. For example, if you define a method named underscore underscore add underscore underscore for the time class, you can use the plus operator on time objects. Let me directly go to PyCharm and show you an example so that you can understand about operator overloading in a better way. Here I am going to my PyCharm, and this is the time class program. Here I use the init method, and then the first argument was self, and then I used 3 more arguments, which are the default arguments: r equal to 0, minute equal to 0, and second equal to 0. Then I set the attributes self.r equal to r, self.minute equal to minute, and self.second equal to second. After that, I use the print time function, which took the default argument self, and then I returned the time in hours, minutes, and seconds. Here, this is the underscore underscore add underscore underscore, or you can call it the magic method, which actually adds and takes 2 arguments. The default argument by Python is self, and then we use the next argument, which is other. So what here we are doing is we are taking a variable x, and here we are adding the values of r from 2 objects, and then we are taking a variable y and we are adding the minutes from 2 objects, and then we are returning the values of x and y. So here you can see that I have taken an object start, which is an object of the time class, and here are the values 9 hours and 45 minutes, and again I have taken a object duration, which is an object of the time class with the values 10 and 35. The 10 is the hour attribute and 35 is the minutes attribute. You can also add seconds attribute. For that we have to change the program, but right now I want to show you what happens when we print start plus duration. I will run my program, and you can see that it has added 9 and 10, making it 19, and again it has added 45 and 35, making it 80. So this is a result of the hour attributes, and this is a result of the minute attribute. So I am getting 19 hours and 80 seconds. Again, if I give the seconds attributes as well, I have to give it like this: z is equal to self dot second plus other dot second, and here I have to give the attributes of the seconds in the brackets. So I will give say 12, and here after 35 I will give say 50 seconds. Now if I run my program again, you can see that here we are getting only 19 and 80 because we are only returning x and y, we are not returning z. That's why we need to return z as well. Therefore I will give z also. Then here the 3 values x, y, z will be returned. Now if I run my program, you can see that 19, 80 and 62 have been returned. So this is how operator overloading is done. And you can also make changes to the program so that you will get the proper time in minutes, hours and seconds. But my intention was to show you an example where you can use the operator overloading method. So now what is actually happening when you are using the plus operator? The plus operator is actually calling this add function, and this is the magic method add. The plus operator here is calling to this method add. So finally, let me tell you the definition of operator overloading. Here I will go to my PDF, and you can see changing the behavior of an operator so that it works with programmer defined types is called operator overloading. So what we are doing in PyCharm is we are actually changing the behavior of this plus. When we are calling this plus, it is actually calling this add method, and therefore we are getting the result here. So this is the use of operator overloading, or the actual definition of operator overloading. Now let us move on to the next topic, which is polymorphism. Here, what actually is polymorphism? The functions that work with several types are called polymorphic. Polymorphism can facilitate code reuse. So it helps us to reuse a certain code in a certain way. For example, the built-in function sum, which adds the elements of a sequence, works as long as the elements of the sequence support addition. So in that case, in our time class, when we define objects, we assign the values of the time. You can see here, this is a object T1 having the time 7 hours and 43 minutes, and this is an object T2 having the time 7 hours and 41 minutes. In the same way, this is an object T3 having the time 7 hours and 37 minutes. Now, if we calculate the total and use the predefined built-in function sum and use the arguments as the objects T1, T2 and T3, and then when we print total of this variable, which is total here, which is assigned the sum of the objects T1, T2 and T3, we should get the particular time here. So let me show you in PyCharm how to do that. Here, this is the class time, and here we have taken three objects. Here this is the first object T1, and this is the second object T2, and this is the third object T3. The hour attributes are here 7 hours for each of them, and the minutes attributes are 43 minutes, 41 minutes and 37 minutes. So if you want to calculate the sum, we can use the built-in sum function, but we have to give the attributes as the arguments. So I have given the attributes as t1.r, t2.r and t3.r. So what finally we will be getting is, when I print the total, we will be getting 7 plus 7 plus 7, which is 21. When I run this program, you can see that I am getting the answer as 21. So what if we wanted to do for the minutes as well? I can do it by taking another variable, total1 is equal to sum, and in the sum function I have to take a list which is t1.minute, t2.minute, and finally the third argument will be t3.minute. So now when I print total 1, what I should get is, I should get the sum of these minutes. When I am running my program, you can see that the result is the sum of this minutes, which is 121. So this is how you can use the sum function. So right now here we have seen the use of polymorphism in object-oriented programming. So what is the definition of polymorphism? I will give the definition through the PDF. The definition is, polymorphism is a process which can facilitate the reuse of code. So in this case, what we did is, we used polymorphism to add the hour attributes and the minute attributes in the program by using the built-in sum function. So the normal built-in sum function can also be used in a program where we are instantiating objects and then adding them together by using the built-in sum function. Now let us move on to the next topic, which is debugging. So it is very legal to add attributes to an object at any point in the execution of a program. But if you have objects with the same type that don't have the same attributes, it is easy to make mistakes. So it is considered a good idea to initialize all of an object's attributes in the init method. In that way, you will not be getting errors, and you will also not commit many mistakes. But if you are not sure whether an object has a particular attribute, you can use the built-in function called hasAttr, as I have shown you in my earlier topics. Another way to access attributes is the built-in function vars, which takes an object and returns a dictionary that maps from attribute names as strings to their values. So here you can see that P is an object of the point class with the attributes x and y, which are 3 and 4. So when we print vars P, it actually returns a dictionary with the keys and values. Keys here are the attributes and 4 is the value, and x is also the key and 3 is the value. So for purposes of debugging, we can have a function like this. Define print attributes, which takes the argument object, and then here is a for loop which actually iterates in the vars object so that it can find the keys and values, and then it will print the attribute and the object name. So let me go to PyCharm where I will explain you better. Here you can see I have this class point. Here in the init function only, or the init method only, I define the attributes here. Then here I have taken another function which is print attributes, which takes the argument object, and then it iterates over the object and prints the attributes as keys and values. So let me run this for you. Here I will show you how to use it. I will first print vars of P, then I will get a dictionary with the keys and values. I will show you. I am running it. You can see I am getting a dictionary with the keys and values. The keys are the name of the attributes x and y, and 2.0 and 3.0 are the values that we provided here. Now if I want to call this print attributes method inside the class, I can do it this way. I will show you. I will delete this hash, and now to call this I am using the object name and then using the dot operator and then calling the method. So when I run this, I will just comment this out and I will run this for you. You will get a similar result. I am showing it to you. Here you can see it says this is the attribute x and this is the attribute y, and these are the values of the attributes 2.0 and 3.0. So this is happening because of this for loop, because it is iterating over the object and getting the attribute and the value. So this is how you can debug your program, by checking whether an object has certain kind of attributes or not, and you can print them on the console. Now let us move on to the next topic, which is inheritance. So the language feature often most associated with object-oriented programming is inheritance. What is inheritance now? Inheritance is the ability to define a new class that is a modified version of an existing class. So what it means is, Inheritance is the property by which a new class takes the properties of an existing class. So here we will learn about how to use inheritance in object-oriented programming. Now I will take an example of cards so that you can understand the topic inheritance in a very good way. So let us talk about card objects. So if you know about cards, you will be knowing that there are 52 cards in a deck of cards, each of which belongs to one of 4 suites and one of 13 ranks. So that means there are in total 4 suites, and in each suite there are 13 ranks. Therefore, there are a total of 13 into 4, that is 52 cards. Here the suites are spades, hearts, diamonds and clubs. The order here is in descending order. So here clubs is of lowest order, then comes diamonds, then comes hearts, and then comes spades. If you don't know about the order, then you should remember this like this: clubs, diamonds, hearts and spades. The ranks are ace or A, then 2, 3, 4, 5, 6, 7, 8, 9, 10, then J, Q, K or Jack, Queen and King. So, depending on the type of game that you are playing, an ace may be higher than king or it may be lower than 2. So, it depends on what kind of game you are playing. The priority or the rank of ace may be higher than a king or it can be lower than the 2 as well. So now if we want to define a new object card to represent a playing card, it is obvious that it should have 2 attributes. The attributes should be the rank of the card and the suit to which it belongs. So the best method to do it is to encode the ranks and the suits so that we can define the object card. So in our program, encoding means mapping between numbers and suites. It does not mean the normal encoding, which means actually converting a message into some secret type of message. In normal languages, encoding is that meaning, but in our program, encoding means we are mapping between the numbers or the ranks and the suits. So here is an example. The table here shows the suits and the corresponding integer codes. So here you can see clubs has the rank 0, followed by diamonds which has the rank 1, then hearts has the rank 2, and then spades has the highest rank which is 3. So it is the decreasing order, or if you go from below to top you will get the increasing order. So clubs is the lowest, diamond is the second highest, then comes hearts and then comes spades. So this code actually makes it easy to compare cards because higher suits map up to higher numbers. So it is very easy to compare suits by compare their codes. So if we compare the codes, then we can tell by the codes which suits come in which ranks. So now the mapping for ranks is fairly obvious. Each of the numerical ranks maps to the corresponding integer. And for face cards, the face cards I am talking about are the Jack, the Queen and the King, or the J, Q and K cards which you see while playing cards. So here this arrow symbol is used to make clear that these mappings are not part of the Python program. It is actually to show that the cards are actually mapped to the ranks. That's it. We are not going to use these symbols in our programs. Right now, let me show a class definition for class. Here is the class definition for class. It looks like this. So here is the class card, and this is the doc string. It says it represents a standard playing card, and then I have defined the init method, which is also known as the constructor. Here the first argument is self, then we have default arguments which are suite and rank. So by this, what you can see is the suite is 0. So you will know that if we go here, as soon as we know that the suite is 0, so the default card is of clubs and the rank given is 2. So you can understand by looking at the suite and the rank what kind of a card is the object. So now these are the attributes: self.suite equal to suite and self.rank equal to rank. So now if you want to create a card, you call card with the suite and rank of the card you want. This is the example. Queen of diamonds is the card. Then I am calling the class card and I am giving the suite and the rank. Let me show you in PyCharm. You will understand better that way. I am going to my PyCharm, and here you can see this is the class card, and the attributes are suites which are integers 0 to 3, 4 suites, and the ranks are 1 to 13. So total 13 ranks. Now this is the def statement with the init method. Here I am defining the attributes which are the suite and the rank. Self.suite equal to suite and self.rank equal to rank. Now when I want to create a new object, this is the way I am doing it. Queen of diamonds equal to card 1, 12. So this 1 is the suite and this 12 is the rank. Now if I print this, say print queen of diamonds dot suite, I am using the dot operator to call the attribute, and in this line also I am using the dot operator to call the rank. So this way we can get access to the attributes. Now if I run my program, you can see that it will print the attributes. This 1 and 12 will be printed here because I am printing the attributes. Queen of diamonds is the object which I have instantiated. Now the suite and the rank of the queen of diamonds card are displayed here, 1, 12 or 1 and 12. Now let us look at class attributes. So what are class attributes? I already told you about the suites and the ranks. So in order to print card objects in a way that people can easily read, we need a mapping from the integer codes to the corresponding ranks and suites. A natural way to do that is with the strings or lists. So we assign these lists to the class attributes. Let me show you how we do that. So inside the class, we use two lists. The first one is the suite names and the second one is the rank names. Here what happens is, in the suite names, as I told you, there are 4 suites which are clubs, diamonds, hearts and spades. I am giving the names, and you can see that the index of clubs will be 0, diamonds will be 1, hearts will be 2 and spades will be 3, because the starting index of a list is 0. And here, because there are 4 items, therefore the index of the 4th item will be 3. So 0, 1, 2 and 3. And in the same way, rank names starts with none followed by ace, then 2, 3, 4, 5, 6, 7 till 8, 9, 10, then jack, queen and king. So in this case also, the index starts from 0 and then I will show you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 items in this list. Therefore, the index will start from 0 and go on till 13 because the starting index is 0, and if we have 14 items, the last index will be 14 minus 1, that is 13. Then we are defining the str method, which takes the argument self, and it will actually return the rank names and the suite names. I will tell you how it will do that. Here, this is the class card and I am using the dot operator. Then it will go into the wrong rank names list, and then it will bring the attribute self.rank. And here it will go to the card class, and using the dot operator, it will go to the suite names list and it will print the self.suite or the suite attribute. So here you can see that variables like suite names and rank names, which are defined inside a class but outside of any method, are called class attributes because they are associated with the class object card. So this term distinguishes them from variables like suite and rank, which are called instance attributes. So here these suite names and suite ranks are actually class attributes, and the self.rank and self.suite are attributes of the object that we instantiate or create. So these two are totally different. So here you can see that the suite and rank are called instant attributes because they are associated with a particular instance or object, as I told you. Now, if we want to print cards or create cards, what we can do is we can create a card object, say card1 equal to card2, 11. And then if we print the card, we will get jack of hearts. Depending on the suite and the rank we provide, we will get the names. Here is just an example. I will show you in PyCharm how to do that. I am going there. And I have the other one for you. I will show it to you. Here you can see that this is the class attributes. Here this is the suite names list and this is the rank names list. And finally, here is the str method, which actually returns the rank attribute and the suite attribute depending on the attributes provided by the object or the instance. It will go into this two lists, and depending on the attributes provided, it will define the names. Maybe it can be ace of clubs, it can be two of diamonds, it can be anything. So here I will show you one thing. I have taken an object or created an object which is an instance, and then I have called the card class and defined these attributes. These are the suites and the ranks. So 2 is the suite and 11 is the rank attribute. Now if I print card 1, I will run it. You can see it says jack of hearts. I will show you how it is happening. So 2 is the suite. So let me go to suite names. What is the 2? 2 will be the index. So I will show you 0, 1, 2. So hearts as the index 2, and finally I will show you here 11 is the rank. So let me go in the rank names list, and finally I will show you 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So jack corresponds to 11. That's why we are getting jack of hearts. So this is a good example how to create an object card with the suite and the rank attributes, and finally we can print the card. So after this, let me go on to the PDF where I will show you a diagram so that you can understand better. Here is a diagram. So here you can see this is the class card and it has the suite names and the rank names, which were two lists. As you can see here, suite names is one list and rank names is another list. And you can decide the type of the card by going into these two lists. And here I created a card 1 which is of the class card, and therefore as soon as I define the attributes suite and rank 1 and 11, then when I printed the card 1 I got the output. So this is a basic diagram of the object cards. Then let us move on to comparing cards. In comparing cards, what we can do is we will take two cards as two objects and send it to a function or a method. Here, how can we define whether one card is greater than or less than the other card or not? So in that case, for built-in types, there are relational operators, the greater than, the less than, and the equal, etc., that compare values and determine whether one is greater than, less than, or equal to another. For programmer-defined types, that is classes, we can override the behavior of the built-in operators by providing a method named underscore underscore lt underscore underscore, which means for less than. So this lt method takes two parameters, self and other, and it returns true if self is strictly less than the other object. So, but how do you know about the correct ordering, or how do you say that the one card is less than the other card? So the answer for that might depend on what game you are playing. But in general, to keep things simple, we will make the arbitrary choice that suit is more important. So all of the spades outrank all of the diamonds and so on. So what I mean to say is, here I will go to the program and show you. You can see the index starts from 0, 1, 2 and goes on to 3. So here spades will have the higher rank in suits, and then will come hearts, and then will come diamonds, and then will come clubs. So a card of spades will be greater than a card of hearts, and followed by a card of hearts will be greater than a card of diamonds, and so on. So this is the logic behind how to use the less than method. Let me go to the PDF once again. Here, let me show you. I have defined the less than function here. You can see it. Define less than self and other. It takes two cards and it actually checks the suits, and you can see that if self.suit is less than other.suit, it will return true, and in the other case, if self.suit is greater than other.suit, it will return false. That means that it will be checking the suit of the two cards or the two objects, self and other, and what it will do is it will check if the suit of this one is greater than this one, then it will return false, but if it is less than the other, it will return true. Then here we are using the return statement which says that self.rank is less than other.rank. What it means is, if the suit of one object is less than the suit of the other object, in that case the rank of the object will also be less than the rank of the other object. So how to implement this? You can see here we have implemented the less than method using self.other, and then we are taking two objects t1 where we are defining the self.suit and self.rank, and finally we are taking another object t2 where we are taking the second argument which is other.suit and other.rank, and finally we are returning T1 less than T2. So let me show you in PyCharm so that you can understand what I am trying to tell you here. Here you can see I have used the less than method. Here it will check the suit and the rank of the first object, and then it will check the suit and the rank of the other object. Finally, it will return T1 less than T2. So here you can see the less than method. Here I have created one card which is card 2,11. When I printed it, I was getting Jack of Hearts. Now let me create another card object, say card 2 equal to, it belongs to the class card, and I will give the attributes, say 3, 12. Now as you can see here, the card 2 has a higher rank than the card 1. Now if you use the less than function, I will show you how to do that. I will call this less than function by using print card dot. You can see I am getting the less than function here. Then it is asking me two parameters, which are the cards. So here I am writing card 1, comma card 2, and here when I run it, you can see that I am getting true. So here I am asking the less than function to check whether self is less than other. What is my self referring to? The self is referring to this card 1, and the other is referring to this card 2. So as we have card 2 has a higher rank, therefore obviously card 1 is less than card 2. So when we are returning this T1 less than T2, we are getting true here. So this is about the less than method. Now let us move on to the next topic or the subtopic, which is decks. So we have cards now, which is a class, and now we can create card objects. The next step now is to define decks. So what are decks? Decks are made up of cards. It can contain 2 cards, 3 cards, and maybe it can contain totally 52 cards. So it is natural for each deck to contain a list of cards as an attribute. So this is an example which will tell you how to define a deck of cards. This is the class deck, and here I have used the init method. Then I have taken the new attribute which is self.cards. So this means it is a deck of cards. Right now it is an empty list. You can see here it is an empty list. But after that I am using the for loop. So what I am doing is I am checking suit in range 4. So it will be from 0 till 3, and then for rank in range 1 to 14. So it will iterate from 1 till 13, and then what we are doing is we are going to the card object, and then we are calling the class card and taking arguments suit and rank. In that way we can define the deck of cards. After that what we are doing is, as soon as we are defining the card, we are going to the self.cards list, and then we are appending this card object here. So in this way we can define the deck of cards. Now let me show you what actually is happening here. I will go to my PyCharm, and here you can see this was the earlier class card, and we had the suite names list and the rank names list, and we use the init method to define the attributes, and finally we had the str method which actually printed the name of the card and the suit and the rank it had, in this fashion so that it is visible easily to the user. And finally, we use the less than function which took two arguments and it returned true or false depending on whether the two cards are less than or equal to. And finally, here you can see I have defined the class deck. And what are the attributes of this deck class? The attributes are, it actually is a list of card objects. Then here I am using the init method. Then I am using the self.cards empty list as I told you in the example. And finally, I am using the for loop to iterate between suits and the for loop for iterating between ranks in the range 0 to 4 for the suits and in the range 1 to 13 for the rank. And finally, I am creating a card object which is referring to the card class and it is taking the suit and the rank as arguments, and then I am appending this card value to the self.cards by using the append method, and then I am giving this card as the argument here. So till now you have understood that a deck should contain certain amount of cards. But how to print the cards is a question. So let us move on to the next topic, which will show you how to actually print the cards or the deck of cards. Now that we know how to define the class deck, let us move on to how to print the deck, because the deck will be having a number of cards. That's why we should know how to print the deck. So let us move on to the next topic, which is printing the deck. Here we have an str method which is defined like this. You can see def str self, and then I have created an empty list which is result or res is equal to an empty list. And finally, I am doing an iteration for the card in self.cards. So it is going to the cards and finding the attributes which are the name of the card and the suit and the rank. And then in the results variable or the list, we are appending the str card. As soon as the str function is invoked, what it will do is it will go to this class deck and finally it will bring out the name of the suite and the name of the rank. And finally, all this will be printed in a string. But we don't want the answer in a single line. Therefore, we are using the /n.join method on the result or the res variable. What it will do is, because of this /n command, it will print the name of the cards in the deck in a manner so that all the names come in different lines. So here I will show you how it is done in PyCharm. Let us go to PyCharm directly. I have already written the program for you. You can see that this is the str method which takes the argument self, and here this is the res empty list, and here this will iterate in the self.cards, and finally it will append the rank and the suite and the name of the card to the result list, and because of the /n it will return the deck of cards in different lines. So for that I am using the .join method, and here you can see I have the deck which is an object of the deck class, and now if I print deck, I will show you what I will get. I am running this program now. Here you can see, I will maximize it for you so that you can understand better. You can see that all the 52 cards have been printed here in the deck of the cards. But all this are coming line by line just because we use the /n command and the .join method. Otherwise, if we did not use this .join method, everything would have come in a single line and it would have been difficult for us to understand the deck of the cards. So this method is very good in representing the deck of the cards in different lines. The name of the cards and the ranks and the suits will be displayed in a different line. So this is about printing the deck of cards. So after knowing how to print the deck of cards, let us move on to the next topic, which is add, remove and sort. So in order to deal with cards, we would like a method that removes a card from the deck and returns the card. So the list method pop provides a convenient way to do that. It will remove a card from the deck and return the card. So you can see that inside the class deck, we can define a function called pop card, which takes an argument self. It only takes one argument. Now when we return self.cards.pop, what it does is it actually removes a card from the list of the deck. So after that it returns the deck. Now since pop removes the last card in the list, we are dealing from the bottom of the deck. As I showed you here in PyCharm, you can see that I printed the deck here. I will do it again for you. I am running the program. So when I use the pop method, this last card from the deck will be removed and the deck will be returned back. So the new deck will have all the cards except this last one, which is King of Spades. Now as soon as we have removed this card from the deck, we also want to add a method which actually adds a card to the deck. So let us see the method then. I will go to the PDF. Here you can see, to add a card we can use the list method, which is called append. So inside the class deck, you can again define a method which is called add card, and it takes two arguments, which is self and card. So here you can use self.cards.append and you can append the card which you want, because by the pop function you have removed a card from the deck. So with this method you can add another card to the deck. So this kind of a method is called a veneer. So what is a veneer now? A method like this that uses another method without doing much work is sometimes called a veneer. So how do we get the name veneer? The veneer name comes from woodworking, where a veneer is actually a thin layer of good quality wood glued to the surface of a cheaper piece of wood to improve the appearance. So here, when we use the add card method, it actually makes the list of cards or the deck of cards to look in a better way. So that's why it is called a veneer method. So in this case, the add card method is a thin method that expresses a list operation in terms appropriate for the decks. So as soon as you remove a card from the deck using the pop method, you can also invoke the add method, by which you can again add another card to the deck. So what is the benefit of this method? It actually improves the appearance or interface of the implementation. So another example is, we can write a deck method named shuffle using the function shuffle from the random module. What this will do is, if we define the shuffle method, it will take one argument self, and then if we use the random method from the random module and use random.shuffle, we can shuffle the cards. So by this way you can shuffle the deck of cards and return a deck of cards which has been shuffled. So this is about the shuffle method. So we have learnt about the pop, add and the shuffle method here. So after you have known about how to create a deck of cards, and then how to print the deck of cards, and then how to use the methods add, remove, pop and shuffle. Now let us go on to the next topic, which is inheritance. So what is inheritance now? Inheritance is the ability to define a new class that is a modified version of an existing class. So as an example, let's say that we want a class to represent a hand, that is the cards held by one player. So what is actually a hand? A hand is similar to a deck. Both are made up of a collection of cards and both require operations like adding and removing cards, because you never know how many cards a hand might hold. So what happens is sometimes a hand might have to add more cards because it will take cards from a deck remaining on the table, and sometimes a hand might have to remove some cards from the hand and put it on the deck available on the table. So a hand is also different from a deck. There are operations we want for hands that don't make sense for a deck. So what I mean to say is the class deck init methods will be different from the class hand init methods, because the operations on hands will not be possibly similar to the operations which we do in the deck class. Therefore, I will tell you an example so that you can understand better. Here is the example. For example, in poker, we might compare two hands to see which one wins. And in other game, which is bridge, we might compute a score for hand in order to make a bet. So in both the cases, in poker as well as in bridge, we might have a different scenario for hands which have certain number of cards. So here I don't want to change the methods in the deck of cards, but I want to change in the hand class. Therefore, this relationship between classes, similar but different, lends itself to inheritance. Inheritance means we will be taking the properties of the parent class and then we will be using them in the child class. But there might be some methods in the child class which may be different from the parent class. So to define a new class that inherits from an existing class, you put the name of the existing class in parentheses. I will show you what I am trying to tell here. Here you can say this is a class hand, but it is a subclass of the class deck. So here deck is the parent class and hand is the child class or the subclass. And here is the doc string which says this hand class represents a hand of playing cards. So what does this definition tell here? This definition indicates that hand inherits from deck. That means we can use methods like pop card and add card from hands as well as decks. So just because hand is a child class of the parent class deck, it will automatically be able to use the methods defined in the deck class. So when a class inherits from an existing one, the existing one is called the parent and the new class is called the child. I have told about this thing earlier. So now here you get the definition. Whenever a new class is created which inherits from the earlier class or the pre-existing class, then the pre-existing class is known as the parent class and the new class which inherits is known as the child class. So let me show you an example so that you can understand better. Here inside the class hand, we are defining an init method which takes two arguments. The first argument by default is self and the second argument is the label. Here I have taken a default argument which is label equal to an empty string. Now here what I am doing is I am putting this empty list into the self of cards and then I am putting this label which is here into the self.label. Now these are two new attributes of the class hand. So whatever object we create in the hand will have these two attributes which are self.cards and self.label. Now when we create a new object which belongs to the class hand, let me show you what happens. Here you can see that I have created a new object hand, and you can see here I have told that it belongs to the hand class, and I have passed an argument which is the string new hand. So this new hand will directly reflect to this empty string, and this label will directly be referring to this new hand string. So now when I try to print hand.cards, I will be getting this empty string, and when I try to print hand.label, I will be getting this new label which is new hand. Let me show you this thing in PyCharm so that you can get a better idea about this. I am going to my PyCharm. Here you can see this is the class deck which I already defined, and after that I will be defining the subclass or the child class. This is the child class hand which inherits from the deck class. Here I have used the init method again, and here you can see I have taken the argument label equal to empty string. Then I am defining the attributes of this hand class which are self.cards and self.label. The self.cards is an empty list, and the self.label is equal to this label which has this empty string. Now as soon as we pass or create a new object which is hand and give this argument which is new hand, and now if we want to print hand of cards, which is the attribute here, as you can see, self.cards will be reflecting in hand.cards. So when we print hand.cards, what we should get is an empty list. This one. Let me run my program for you. I will show it to you. Here you can see the empty list has been printed here. Now again, I will go to the PDF and I will show you what else can be done with this. So as I told you, the other methods which are defined in the deck class can be inherited by this child class, which is the hand in our case. The methods which are defined in the parent class deck were popcard and addCard. So let us try to use those methods to deal with a card. Here you can see that this is the first object of the deck class, and here I have created another object which actually calls the popcard method in the deck class. And after that I have tried to call the addCard method by using my hand object, and then when I print my hand, it says king of spades. So what actually is happening here? Here when I use the deck.popcard, actually the pop operation removes the last card from the list, and again when we add card, the removed card will be again added to the hand. So right now when I print hand, I will have this king of spades. So let me show you how to do this in PyCharm so that you can get a better idea. So here in PyCharm you can see that I have instantiated an object deck which belongs to the deck class, and then I have used the popcard method. What this popcard method does is it actually removes the king of spades from the list of cards or the deck of cards. So the deck of cards, as I showed you, will have 52 cards, out of which the last one, which is the king of spades, will be removed or popped out. And then I have created an object or an instant hand which belongs to the hand class. Now I am using the addCard function or the method which belongs to the deck class, but because the hand class is inheriting the methods from the deck class, therefore I am able to use this methods. So when I give hand.addCard and pass the card here, this card, then what it will do, it will add the earlier removed card to the deck of cards. Now if I print this hand, you can see that which card I have added. I will run this program for you so that you can get an idea. I am running it. You can see this was the added card, the king of spades. As I told you, this is the last card in the deck of cards. So this is about inheritance. Here this deck is a different class and this hand is a different class, and this deck is the parent class and this hand is the subclass or the child class which actually inherits properties or methods from the parent class. And here, as soon as we are using the add card method, we can see that it has added the king of spades to the deck of cards. So now let me go to the PDF and tell you what I can do more with this inheritance properties. Here again, I can define another method in the class deck so that I can move cards, and whenever a player uses cards and move cards between player to player, then this function will be very useful, so that if there are 3 or 4 players, the cards can be moved from the hand of one player to the hand of other player. So here, this is the move cards method. Here it is taking 3 arguments, self, hand and number. What it will do is, it will change the cards from one hand to other hands depending on the number. So here, if the number is 2, it will move the cards from one hand to 2 other hands. So here I am using the for loop, and it will iterate in the number range, and then it will add cards, and inside the add cards you can see self.pop card. So as soon as a card is removed from one hand, it will use the pop card function, and then it will use the add card function so that the same card gets added to the hand of the other player. So this is what is happening here. So here you can see move card takes 2 arguments, a hand object and the number of cards to deal. Then it modifies both self and hand and returns none. So this is about inheritance. So as you have learnt about inheritance, now you know that a parent class will have certain properties which will be inherited by the child class. So in that way, it will not modify the parent class, it will be able to modify the functions or the methods in the child class, and at the same time it will also be able to use the methods that are present in the parent class. So this is the best use of inheritance. Now as you have known about the definition of inheritance, let us move on to the next topic, which is class diagrams. Till now we have seen stack diagrams which show the state of a program, and object diagrams which show the attributes of an object and their values. These diagrams represent a snapshot in the execution of a program, so they change as the program actually runs. Now let us move on to the next type of diagrams, which are known as the class diagrams. So a class diagram is a more abstract representation of the structure of a program. Instead of showing individual objects, it shows classes and the relationship between them. So there are actually several kinds of relationships between classes. Let me show you by the diagram. Here you can see this is the diagram here. So this is the class deck, this is the class card, and this is the class hand. Here what actually is happening, I will explain you. The first thing that is happening is objects in one class might contain references to objects in another class. So here the objects in this card class will have references in the deck class, because what does the deck class contain? It contains a number of cards. So this number of cards will be there in the card class. And what does the hand contain? Hand contains a deck of cards, and that's why this hand is directly related to this class. Therefore this deck is called the parent class and this hand is called the child class. And this kind of relationship is actually called a has a, as in a rectangle has a point, or a hand has a deck. And the second point is one class might inherit from another. This relationship is called is a, as in a hand is a kind of a deck. So therefore the is a relationship is between this deck and this hand, because the hand is actually a part of the deck class. So that's why this kind of a relationship is known as the is a. And the third one is one class might depend on another, in the sense that objects in one class take objects in the second class as parameters, or use objects in the second class as part of a computation. This kind of relationship is called dependency. So this diagram explains the dependency of one class on another. So I will explain you about this diagram in detail now. Here the arrow with a triangle head represents an is a relationship. In this case, what I mean to say is the hand actually inherits the properties from the deck class, and the normal arrow represents a has a relationship. In this case, a deck will have only references to the card class. It is not inheriting anything from the card class, it is just taking references from the card class. So deck class is taking references from the card class, and by the star here you can mean that it says multiplicity, because the deck card means that it has a deck of cards. So the card class multiplied by a certain number of times will give the deck class. That means deck of cards will have many number of cards. So when the card class is multiplied with certain numbers, you will get a deck of cards. This is called the multiplicity, and this is about this class diagram. So let us start with the debugging process for inheritance. As we all know, inheritance can make debugging very difficult, because when you invoke a method on an object, it might be hard to figure out which method will be invoked. So I will give you an example here. Suppose you are writing a function that works with hand objects. Then you would like it to work with all kinds of hands like poker hands, bright hands, etc. The poker hands and bright hands are the names of games. So now if you invoke a method like shuffle, you might get the one defined in deck, but if any of the subclasses override this method, you will get that version instead. This behavior is usually a good thing, but it can be very confusing because you will not be knowing which class you are calling to invoke the method of that class. So in that case, anytime you are unsure about the flow of execution through your program, the simplest solution is to add print statements at the beginning of the relevant methods. If deck.shuffle prints a message that says something like running deck.shuffle, then as the program runs, it traces the flow of execution. By that, you will be able to know which class the method actually belongs to. Or else you can do one more thing. As an alternative, you could use this function which takes an object and a method name as a string and returns the class that provides the definition of the method. Here is the method I am talking about. Here you can see def find defining class. This is the name of the method, and it takes two arguments which are object and the method name. So here what it will do is it will iterate in the type of object dot mro. I will tell you what mro means. And what it will do is, if it finds that method name is in the type of the dictionary, then it will return the type. Here is an example. You can see here, I have created or instantiated an object hand which belongs to the class hand. Then if I run this find defining class method and give the arguments hand and shuffle, then it will print it belongs to the class card.deck. So this means that the shuffle method for this hand is in the one in deck. So we are invoking the method from the deck class. So this is very easy to understand when you use some methods like this. I will show it in PyCharm so that you can get it better. Here I am going to my PyCharm, and this is the total program where this is the class card and this is the class deck, and finally here I have used the method called find defining class. Here I am using two arguments which are object and the method name. So what happens is it will iterate over all the classes, and if the method name exists in that class, then it will return the name of the class, and if the method does not exist in the class, then it will return none. So let me tell you what this MRO method means. The MRO method means, I will show it to you here. The find defining class uses the MRO method to get the list of class objects or the types that will be searched for methods. MRO stands for method resolution order, which is the sequence of classes Python searches to resolve a method name. Now, what is this MRO method doing? I will show it in PyCharm. As soon as you use the MRO method, it will search the whole program and search all the classes like the hand class, the deck class, and finally the card class, and it will search for this method which is clear. But in our program we do not have any method called clear, as we already know. So when I run this program, I should get this none as a return value. When I run this, you can see I am getting none because none is not a method in any of our classes. Now if I give a method which is available in the classes, say shuffle, and then if I run my program, you can see that this shuffle actually is referring to the class which is main.deck. So the shuffle method actually is in the deck class. I will show it to you here. You can see this is the deck class, and here we have the shuffle method here. So by using this method, we can find out which method we are invoking and from which class. Now if I give say some other method, say add card, and then run my program again, you can see that it is also existing in the deck class. So this is how it becomes easier to debug your program, because inheritance makes it very difficult in debugging, because you will not be knowing where the method we invoked belongs to or which class the method we invoked belongs to. So in this way you can actually find out which class the method we invoked belongs to.
So this is all about this video, guys. Thanks for watching. Hope you liked the video, and if you like it, then tell us in the comment section below. If you have any doubts, then post them in the comment section. I will definitely try to clear those doubts. Also, like, share and subscribe to our channel Coders Arcade and press the bell icon so that you will get a notification when we post a new video. Thank you. Happy learning.